We're going to continue with the example that we had last time, and I even have the projector on today, so I'm doing pretty sharp today. I got the Starbucks application for my phone, so while I'm sitting, well, I probably shouldn't say this because it might be illegal, but while I was sitting at a red light, I was ordering my coffee, so it was ready nice in time. But anyhow, and this is not a paid endorsement for Starbucks. Anyhow, I should just get going with the class and not get myself in trouble here. We're going to go over the example that we started last time, and there's some key points to get from this example. And of course, there is the PHP syntax, you know, what the code looks like in PHP, how to do an if statement, how to validate server side, how to display stuff on the screen, how to write a function, how to do a calculation, and so on. There's the PHP syntax. But just as important to that is the aim is to get you to write good code. All right. Now, good code is vague, right? What can we say about good code? Well, first of all, it works, right? If it doesn't work, it's probably not good code. But you know, that's just the baseline for good code. That is, I guess if I was assigning a grade to it, that is maybe a C, you know, if you have code that works. Well, what elevates it then to be good code? Well, following good software development principles. And those include things that we talked about. And just to review, 1, DRY, do not repeat yourself. So therefore, if you have a calculation, like in this case, we need to calculate the range of the optimal range for exercise heartbeat based on your age. We do that in a couple of places. All right, we did it on a chart last time, and we're going to do it on a form this time. But the code that actually calculates that range is only in one place. All right, it's not like there's a different equation on the chart than it is on the form. So we don't repeat ourselves. That's like job one, you know, once we, you know, besides it working. All of these things fall under the general category of being easy to maintain. So do not repeat yourself. If the Heart Association comes out with a new guideline for exercising and they change the equation to calculate the range, the optimal range of your heart rate for exercising, if the code's only in one place, we only have one place to change it. And we can make that change, and it will be throughout the application. So that's the key thing with that. Another thing is separating. I'm not going to even put that in there because that is sort of, but not really. Next, I would say write good functions. What do I mean by a good function? A good function is self-contained. The only way that you pass data in is through the arguments. And the output of the function is the return value. So for example, we're not going to write a function that pulls data from a form to do the calculation of heart rate. Why aren't we going to do that? Why did we accept an argument for that function? We accepted an argument because we want to use that in multiple places. We want to use it when we have a loop on the chart where we loop through and calculate the rate for different ages. We want to use it with the form. So we want to use that calculation in different places. And if that code is coupled, that term is, to the interface, in other words, it uses things in the user interface, then that makes it tougher to reuse. It's another guideline or easy to maintain, reusable code. Fault tolerant. Doesn't blow up if there's an error. All right, if there's a problem of some kind. It ends gracefully. It informs the user of what's wrong in understandable terms, not in computer speak. And it tells them what they need to do to correct things. All right. Other thing about a function is it only does one thing. And I had another thought in mind. I am going to add the separate one. Separate user interface from, I'm going to say business rules, or I'm going to say business rules, but it's not necessarily always a business. It's whatever your organization is doing it for. Like if this was if this was a heart society displaying the exercise rates on their page, then, that would be the quote business. Or if you did it for a school, you don't think of a school as being a business or a nonprofit organization. Or even if you did a game, it's not that's not a game is not a business, but it would still call the rules for that game sort of like the business rules. So we'll separate the user interface from the business rules. So let's look at what we did last time and see how it follows these rules. Oh. And way down, maybe not at the bottom, but somewhere in there, is that its efficiency. In other words, if you have one set of functions that can do something quickly and one that takes a while to do it. And again, taking a while in computer terms is relative, of course, but more efficient the code is. All right. So let's look at the chart from last time. I have this example and I'm going to move it into my special place. My web server's root, which is C inet pub ww root. And I run it by typing in localhost. And here I go. We did this chart last time. All right. Right now, when I talked about good programming practices, I'm talking mainly about true programming like PHP code or like C# code if you were studying that, or Java code. I'm not really talking about HTML, which is not truly a programming language. All right, so let's look at our functions for this. All right, chart. All right, this is the user interface. All right, this is the web page that the user is going to see. And it has a table. It has code that glues together our user interface with the business rules, but none of the business rules are written here. In other words, I don't do the calculation for your optimal heart rate range here. All right. I have code that glues this to the business rule functions that are in the include file, but I don't explicitly have any business rules here. It's okay to call a function in the user interface. You're going to have to do that, all right, to connect your HTML to the PHP. But I'm not actually doing any of the heavy lifting, any of the business rules right in the user interface itself. So we look at these functions, calculate minimum exercise rate, maximum exercise rate, and maximum overall rate. And they're in this heart include. All right. So these are the three functions that are relevant right at the top. Now, are these functions, let's bring up our list. Let's try to get these side by side. Does it work? Well, I'm assuming it works. I actually, when I wrote this, I did the calculations by hand and compared it. I ran it through several test cases and found that it indeed works. So we'll check that off. Did I repeat myself? Do I have the calculation to calculate the maximum rate in more than one place? I call the function. It's okay to call another function, but the actual business rule of this, is that in more than one place? No. Anytime I need to do that calculation, I call this function, and that's a good thing. Is it self-contained? Is it not coupled to the web page? It isn't, and that's good. It accepts the argument that it needs. So this argument could come from anywhere. In the case of the chart, it comes from a loop. In the case of our form calculation, it's going to come from the form itself. But I'm not pulling this from a form somewhere on the HTML of the page. And I'm not outputting the results somewhere on the page. I'm getting the input, everything that the function needs. In this case, it's only one value, the age, and I'm outputting the result. So yes, it's self-contained. Do these functions do one thing? Yes. This calculates the maximum rate, maximum exercise rate. Oh no, this one does a maximum rate. This one does a minimum exercise rate, and this one does a maximum exercise rate. Reusable code? Yeah, we're going to see how this is reusable in a minute when I use it on the form. And finally, is it fault tolerant? Well, nothing can really go wrong here. The fault tolerant piece is going to come in when we look at the chart, or not the chart, the form. Because in the fault tolerant one, you have the chance to enter in bad data. Here we know those functions aren't getting bad data. So they're going to get 20 through 80, right? So as long as these functions can handle 20 through 80, they can, then we're in good shape. So yeah, fault tolerant is yet to be determined, and we'll see that when we look at the calculation from the form. All right, so let's look at the calculation from the form. I go here, and this does something a little bit different. I type in my age. I type in how many beats per 6 seconds. They usually recommend that, like in a gym, if you're doing this, you know, because it's easy to just time for 6 seconds instead of timing for a whole minute. So let's say my rate was, there was 10 beats in that 6 seconds. Okay, this doesn't return any values, any numerical values. This simply returns that I'm in the optimal heart range. Now notice something about this. All right. Notice that we're on a different page here. We went from this page, which is called Calculator PHP, to this page, which is called Check Range PHP. You might not like that, but this is our starting point. We're going to see how we can do everything on one page later on. I don't know if we'll get to it this week. If not, we'll get to it next week. All right. And why don't I like it? I don't like it for this reason. Okay, if I type in garbage for the age, oops. All right. I split the validation between client and server. In a real application, you would do all the validation both on the client and the server. But if I wrote the client side validation to do everything, then I wouldn't be able to demonstrate the server side validation to you. So I broke down the server side the validation to 2 steps. One is to make sure that you enter something for age. The second is to make sure that we have entered in a number for age and a number for beats per second. So this validation right here happened on the client side. This validation here happened on the server side. And we can see that because we went to that server page, that second server page, and we passed the data on the query string. All right. So this does validation in both places. I hope that's not confusing to you. All right. But there's no other way for me to illustrate server-side validation easily other than limiting the client-side validation. I guess I could go to the trouble of disabling JavaScript and all that, but I didn't want to get into that. All right. So let's look at calculator. It's really important to keep in mind what is done where. So this page, when I initially load it, this HTML comes up. That includes a form. The action is check range PHP. The method is get. On submit method is validate form. Remember, when you have code on an event like this, this is client-side JavaScript code. So we're going to call the validate form function that exists on the client within JavaScript. We then have our 2 text boxes, and away we go. Now, I think I talked about the validation last time, but I'll spend a minute talking about it. The validation returns, as validations typically do, a true or a false. So it validates the form. In this case, all it does is see if there's a value in the text age. If not, there is no value. It sets the page to being invalid, and it sets the error string to missing age. We then display the error string, and we return be valid. Well, what does it mean that we return be valid? What does it get returned to? It gets returned to whoever called it. Who called it? This onSubmit event called it. Now, it's a little confusing, but validate form returns a true or false. That true or false in turn gets returned to the onSubmit event. And the way it works is like this. If the onSubmit event gets a true, then it's okay to submit the form to the server. If the onSubmit method gets a false, then it cancels the submission. So in this case, as we saw, if we don't enter anything here, then valid is going to be equal to false. That returns to this onSubmit event, and boom, we cancel the submission. If it is valid though, then we go to the other page, passing the data on the query string, because again, we use the get method as opposed to the post method. Okay, so let's start looking. That's all we're going to look at the calculator page. I'm going to look now at the check range page. Let's see what it does. All right. I have the include for the heart include, which is good. This is the same calculations that the chart uses. Both of them include the same include file. That's good, right? Because we want to have all that code in just one place, and we want to reuse it. We want to reuse the same code here that we did on the chart page. I also have a new include file called check range. Now, I'll be honest with you. I put this in an include file, but this code doesn't really have to be in an include file. In a way, I kind of regret doing that. I wish I didn't put it in an include file. Why do I say that? Well, all the other include files are in include files because they're reused on many pages. So this header inc is included, this nav inc is included, this footer inc is included, the heart rate is included because they are used on multiple pages. They're used on the check range page, and they're also used in the chart page. So there's a good reason to put those in include files. This check range include file is only for this page, the check range page. So I really didn't need to put it in include because we're never going to reuse that portion of the code. The check range include includes code that glues this form or the data that we've gotten from that form to the calculate functions. All right. Again, remember, I'm using INC here for include. It's better if you use PHP. That would be another thing I would change about this, example. It's more secure if you use a PHP instead of an INC. All right, so let's look at what check range does. It calls validate form. Is that validate form in JavaScript or PHP? It's in PHP. Right here, we're in PHP land when we have these declaratives. So this calls the validate form in PHP. If it's valid, then we display the output. If it's invalid, then we don't do anything. So where is this stuff at? Well, this stuff, these functions, validate form and display output, are in check range. Now, one reason I probably put it in an include file when I originally did it is look how clean this page is. This page has almost no code on it. It just has include files and this little snippet of code here that does very fundamental things. Validates the form, checks to see if the form is valid or not, and if it's valid, display the output. So let's look at this other include file to see the actual work that goes on. All right, first thing it calls is validate form. So we're going to do like we typically do. We're going to assume the form is valid and set it false if we find an error. As I mentioned before, that's the easier way to code it. It becomes very complicated if you try to code it the opposite way. That is, assume the form is invalid and then try to validate that it's true. If we assume the form is valid, all we have to do is find one condition that happens to be false and the whole form is invalid. Whereas if we tried to prove that the form was valid, would have to prove that all those conditions were true. So I pull from the age, I pull the age and the beats from the request object. The request object pulls the value from the query string. Now, you may be thinking, if you're paying attention, there's a penalty here, flag down. What's wrong? I'm communicating with the web page itself by doing that. All right? And you're right. This doesn't get past any arguments. Why is this okay? Or why am I saying that it's okay? It's okay because this is where we have an addendum to the bottom of the list. The rules are most relevant when we're talking about code we want to reuse. There will be code that glues the UI to the business rules. The rules are more flexible then. In other words, the reason why it's okay to do that here is I don't have any plans of ever using this include file anywhere else in my application. This is written specifically for this page. Again, I put in an include file, but I wouldn't have to. All right. So we're more lenient with the rules here. So pulling it from the query string is okay. I then have a series of checks. I check to see if is set age. That means does age have a value? If it doesn't, then it's not valid, and I print no value for age. This is also a case where I'm not returning something to the function that called it, but instead I'm actually writing directly to the page. That also sort of validates this rule. But again, this is code that glues the UI to the business rules, and the rules are more flexible. I do the same thing for beats. I look to make sure that age is numeric and beats are numeric. This exclamation point before function means not. So if age is not set, and what does set mean? It means that it has a non-null value. It's not empty and it is not null, and it has some value. So if it doesn't have a value, then we have a problem. Likewise with beats. Here, we're asking the question if it is numeric. So if it's not numeric, we're essentially asking, is it not numeric? So is it not? No, we're asking here, is it not numeric? I got an extra negative in there. My mistake. We're asking, is it not numeric? If it's not numeric, we do this. So again, we're writing right to the web page, but that's okay. And we do the same thing for beats. So this function returns the valid flag.
Do you make that a repeat? Two is not numeric, like the age and the beats.
Yes, you could. You could, okay, and that's a good point because do not repeat yourself. All right. I could do something that looked at every item on the query string and made sure that there was a value for it. So I could write a script to do that. Again, though, the rules are more flexible here. I'm less interested in doing that because this isn't code I'm going to reuse. So instead of taking, a half hour to write code that would loop through everything, I take 10 minutes and copy and paste, So it is a shortcut, but you're absolutely right. You could do that for this as well. So the bottom line is this returns either a true or a false. It returns a true if the data on the query string is valid. It returns a false if the data is not valid. So where does it return it to? It returns it to here. If it's valid, then it goes and calls display output. All right, what does display output do? All right, it again grabs the value from the query string for age and beats. It calls a function we haven't looked at yet, and we'll save this. We'll look at this in a minute here. But this function checks to see if that age and number of beats is within the range. And it passes a 6 because the input was supposed to be for 6 seconds. This function here in range, we'll see in a minute, returns a -1, a 0, or a 1. It returns a -1 if you're below the range. It returns a 0 if you are within the range, and it returns a 1 if you are above the optimal exercise range. So, again, this calls that function. There's a function that determines if we're in the range. And that function, because we could potentially reuse that on another page, we applied our rules of good functions to. This one, again, is a glue function. It's associated only with check range PHP. So I'm less concerned about following the good rules. Okay, it's not like I'm not concerned at all, but I'm less concerned. Okay, so what does that function in range do? Hey, I did a good job for once and commented the code. Be like me in this paragraph where I document the inputs, document the return value. really, if you want to be nice to your fellow programmer who might come along later and maintain this code, or if you want to be nice to yourself, and because, you know, when you work on so many projects, you don't necessarily remember every piece of code that you write. So you put comments in that explain things. And really, the comments you need for a function, these are really important. Defining what the inputs are and defining what the return value is. So I do this calculation of beats per minute. Notice I made this a little more flexible. I could have hard coded this for 6 seconds, but I made it an argument just in case I wanted to use this function somewhere else. Calculate beats per minute. I calculate the maximum and the minimum, and then I check to see if beats are lower than the minimum, then I return a -1. I set my answer to -1. If beats are greater than the maximum, I set my answer to 1. If beats are greater than equal to minimum and beats are less than or equal to max, I set the answer to 0. Then I return the answer to here. We take that answer and display the proper message. Now, you might say to yourself, I could make this a little more efficient if I used ifs and else's here. And that's true. But you know what? This is doing 3 if statements. The readability and the ease of programming these 3 statements, in my mind, make up for the fact that they are slightly less efficient than writing ifs and else's. Ifs and else's are one of the biggest causes of confusion in programming, especially if you have multiple ones, because you really have to look how they're nested in order to determine like what happens when. So I said, I'm going to take the inefficiency here and write 3 separate if statements, but they're real simple if statements. So we end up, the bottom line is we end up with this. If I don't put the age in, client side catches it. If I put something non-numeric in, I call the server, the validation on the server catches it and outputs these messages. If I put something valid in for these 2 form fields, then we actually do the calculation and display the output. Now, is this fault tolerant? Yes, because what could go wrong with this? What could go wrong with this is we don't enter something in a field or we enter something non-numeric, and our validation covers those things. So yes, we made it fault tolerant. Did we repeat ourselves? Not really. At least in the functions that are reusable, where I'm checking the range, I'm calling a function in range, and that function is calling the maximum exercise and minimum exercise rate. So that rule of calculating the minimum and maximum exercise rate only exists in this function. So again, if the doctors come up with a new guideline for calculating the exercise rate, only have to change it here. All right. Now, I always like to, in class, sort of have a cliffhanger at the end of class, you know. I used to like, I don't know, shows probably do it now, but I used to like to show Alias that was on a lot of years ago. And they would have the story, but like right before the end of the hour, there'd be, you know, the main characters would somehow get in trouble again, and it would look like they were doomed. All right. And then you had to turn in next week to see the results of it. So I'm going to try to set up a little cliffhanger here. All right. I mentioned before that, well, let me show you what I mentioned before. If I put in garbage for something and click calculate, let's say, you know, these are obviously wrong, but let's say I type in, I hit the wrong key and I meant to type in 12, but I type in Q2. All right. I can click calculate. It will tell me that the beats are not a number. First of all, that might be confusing to me. It's like, I know I typed 12 in there. You know, you didn't, but you might think that you know that you typed 12 in there. Well, I don't see what the previous entry was. And to correct it, I have to go back or click calculator again. Either one of those two things will take me back to the calculator page, and then I can enter in the right values. I don't like that. I don't like the fact that you have to either hit the back button or hit calculator again to go back to the calculator page. I would rather have it so that if there were server-side errors, it would display on the same page. So how are we going to do that? All right. How are we going to make it so this calculator displays this way initially and displays all the server-side errors if they've entered in something invalid? Well, there's good news. We can do that. Maybe this isn't a cliffhanger. I'll demonstrate what it is, and we'll talk about how to do it next time. All right, I'm able to accomplish that by doing what's called a post back. Browser. There's a calculator post back here. The technique when you have a single page that both has the form to enter data and also displays the results is called a post back. So now, if I type in something valid, it displays right on that page. If I type something invalid, it displays the errors on that page. Now, one thing you might say about validation is I probably should have a limit. Like I shouldn't be able to type in that you had 20,000 heartbeats in 6 seconds. So it could be better fault tolerant. But everything happens on this one page. So we'll look next time at how that happens, how we can make that happen. It involves keeping track of what mode the page is in. Are we in the mode of entering data, or are we in the mode of processing the results? All right, are there any questions? All right, we'll either see you in lab or we will see you next time.